Hi guys, welcome back. Hope you had a nice week. I'm going to start by correcting your homework from Friday. Okay. No. Sorry, hang on, just waiting for my iPad to update here. Yes. Okay. So your homework from Friday was these 3 questions on squares and rectangles. Okay, so the first one we actually discussed in class. So to get the area of this is nice and easy. We just multiply length by width. Okay? Problem with this is that the units don't match. So I have meters here and I have kilometers here. Okay? Can't have that. So you can go either way. I'm going to convert my 1.3 kilometers into however many meters. Yeah? So I'm going from a big unit in kilometers to a small unit in meters. So that's going big to small. So that means I multiply. So what do I multiply by? How many meters are in a kilometer? So the K in kilometer, the kilo, means 1,000. So I'm going to be multiplying by 1,000. So I take 1.3 and I multiply it by 1,000, and that gives me 1,300 meters. So now I can do my question. It's going to be length is 1,300 multiplied by width is 820. So that gives me 1,066,000. And I went with meters, so that's meters squared. Sorry. Now, if you went the other way, just in case, and so you have it. So if you left it as 1.3, and you converted your 820, you should have got 0.82. Because in that case, you would be dividing by 1,000. So 820 divided by 1,000 is 0.82. Yeah, and you multiply that by 1.3, so that would be, 0.82. I just totally typed the wrong thing. So it's 1.066, and that would be kilometers squared. Okay, so it doesn't matter which one you did, just make sure you got one of them. So 1,066,000 meters squared, or 1.066 kilometers squared. Okay, the next one here, find the area. So this is a compound shape, so we'll have to split it. I'm going to split it here and make a big rectangle and a little rectangle. Okay, so I'll start with the little one, I think. Yeah, we'll call this number 1 and call this number 2. So number 1, the area is length by width. Let's see, the length is easy enough to see, there it is there, 5, multiplied by a width, so that's here, so let's see. Okay, so it tells us that this bit here is 7, see, it says it's 7, and then it says that the whole thing here is 9, so that means that little bit up here is going to have to be 2. So that gives me an area of 10 for that one. And then for the big rectangle, which I'm calling part 2, still a rectangle, so it's still length by width, and the length in this case is, there it is across there, so 14 multiplied by a width going this way, so that's a width of 7, so that gives us 98, and then you add 10 and 98 to get 108, and it's centimeters squared for area. Okay, and then the last one, a landscaper plans to plant a lawn in a garden as shown. The rectangular lawn will be 12 meters long and 6 meters wide. It has to be surrounded by a uniform path of 2 meters wide. Find the area of the lawn. Okay, so the area of the lawn should be straightforward enough. So the area of the lawn is length by width, which is 12 by 6. Yeah? And 12 by 6 is 72 meters squared for the area of the lawn. Find the area of the garden. Okay, so the garden is this whole shape. Do you know what I mean? It's the grass plus the path. Okay, so the area of the garden is still a rectangle, so you're still going length by width. Now the length. So the length across here, actually, sorry, let me get rid of all. Hang on. Okay, so the length going across here, you see where I am? Right. To here is 12. Right? But then on the left you have a 2 meter path, and on the right you have to have a 2 meter path because they said it wanted 2 meters the whole way around. So that means the length of the entire garden is 12, what's that? 16? And then for the width, you have the same thing. So we'll just get rid of that. So for the width, you have this bit here, which is 6 meters. And then you've got 2 at the bottom and 2 at the top. So that's going to be 10. So that's 160 meters squared for the area of the garden. Okay. Part C says find the area of the path. Okay, I'll move this now. I am writing. Okay, so hopefully you can see this, but to get the area of the path, right? So we know this area, the area of the garden. Yeah, that was 160, wasn't it? Yeah, 160, right? And then we know the area of the grass. It was 72. So if we want to get the area of the path, all we have to do is minus them. So you have the total garden, which is the 160. Try and imagine like taking a scissors and cutting out the 72 of the grass in the middle, and that would leave you with kind of the frame, which is the path. So I think that's just a subtraction. So we just do 160 minus 72. So that's 88 meters squared. Sorry, I am doing this. There you go. 88 meters squared. And then the last one says, find the cost of paving the path if it's €12 per square meter. Okay. So it's €12 per meter squared, and we need to do 88 of them. So if we do 88 divided by 12, no, sorry, it's €12 for 1 meter squared, and we want to do 88 meters squared, so we just multiply by 88. Yeah? So it's going to cost €1,056 to do the path. Sorry. So it's €12, yeah, for 1 meter squared. We need to do 88 meters squared, so it's just 88 of them. So €1,056. Okay. Good. So we'll pop back in here and have a look at what's next, which is nets. Okay. So I don't know if I feel like you do nets in primary school, just from what people have told me over the years, but I could be wrong. Where am I? Okay, here. So nets. So nets are two-dimensional representations of three-dimensional shapes. Just realized that went completely off the page. There you go. So it's two-dimensional representations of three-dimensional shapes. So if you take like, it would be like getting a cardboard box and then, you know, opening up the lid, cutting down all the seams and flattening it out on the ground. That's a net. Or like taking, you know, the internal bit of a toilet roll, you know, the bit in the center, the cardboard bit, and cutting it and make it flat. Okay, so it's taking something that's three dimensions and basically flattening it out. That's a net. Okay, it's a method of calculating area, because rather than calculating it looking at the three-dimensional shape, you flatten it out and it's much easier to see what you're dealing with. So look, they have a couple there. There's a cube, and you flatten it out. A cube has 6 sides, so you can see there we have 1, 2, 3, 4, 5. There's your 6 sides. Okay, another net of a cube, 1, 2, 3, 4, 5, 6. So if you were to take either of these, as in if I gave you either of those, you would be able to fold them up and make a cube. Yeah? And this is actually, I've had this asked at like quizzes I've been at. How many possible nets are there of a cube? There's actually 11. And it's hard to find them all. I normally do this actually if we were in class, see who can find the most. I think the most the students ever gotten is like 8 or something in the 15 minutes that I give. And you can see the one above. So this shape, so when it's not a cube, so a cube is a three-dimensional square. Yeah, so the length and the width are the same, and then ultimately so is the height. This thing here is called a cuboid, and a cuboid is a three-dimensional rectangle. So you don't have the same length and width, yeah? And then there it is there, folded out. Yeah? Okay, so you have to be able to draw nets from three-dimensional shapes, okay? They have to be drawn quite accurately. At ordinary level, you only need to be able to draw the net of a rectangle or a cube, but at higher level, you can be asked for different shapes. So, just different three-dimensional shapes. It might be like triangular in the front, you know, but have depth. So you have to be able to unfold that, and you know, obviously you'd have a rectangle at the bottom, 2 rectangles at the side, and then 2 triangles or whatever. Like we'll do a few, but yeah. So you have to be able to draw them, and you have to be able to draw them quite well. So I'm going to draw one, because I don't know how much this is going to. Anyway, okay. So I'm going to start with the big one. So here, yeah. So that is. I'm going to try and do this with this. I don't know if it's going to work. Let's give it a go. So 1, 2, 3, 4, 5, 6, 7, 8 by 1, 2, 3, 4. Yeah? So that's 8 here and 4 here. I'm using 1 square equals 1 centimeter. Yeah? Okay. So now I always use, when I'm doing rectangles or cubes, I always use the T shape. I just think it's a bit easier. Okay. So if you imagine now, I've just drawn that there. So that's that. So this side here, okay, it's going to be, go away, it's going to be 2 centimeters this way and then 4 centimeters down. Make sense? So 4 and 2. And then you can't see it in the 3-dimensional one, but you have another one of them there. So I'm going to put that on the other side. So starting here, I'm going to go 2 centimeters out and 4 centimeters down. Yeah? So now I've done the top and then I've flipped up the 2 sides. Okay? So next I'm going to do this one here. Okay? Just to the bottom of what I have the black star on. Okay? So this front one here. So that one is going to be 8 across and then 2 down. Yeah, so that's going to be 2 there. I'm going to have to move down the next example a bit. Okay, so now the next bit of the shape is the underneath bit. Yeah, so like the bottom of the shape, which is the exact same size as the top. So it's going to be 8 by 4 again. So insert my rectangle and we'll go 8 across and 1, 2, 3, 4 down. Like that. Eight across and 4 down. And then the last side is the side at the back here, which is facing the front. So it's going to have the same dimensions, which is 8 by 2. So one more, insert rectangle, 8 across and 2 down. And that there is your 2. So there is the net of that shape. Okay, that's the idea. You would obviously need to do that with a pen, a piece of paper and a ruler. Or you could do what I did, because obviously your exam paper will have squares on it. So you could just say like 1 square is 1 centimeter and work from there. But that's it. Okay, now I know this is one thing with area and volume. It depends how good you are with your spatial awareness. Some people are very, very good at unfolding those shapes in their mind and they can see what it looks like. Other people really, really struggle with that. So it just takes practice. What I would suggest, if you're really struggling to mentally picture it, I would make it. I'd get a piece of paper, measure it out, cut it up and actually make it, fold it and unfold it. I have some shapes in school. It actually might not be a bad idea. I might pop in and get them. Just so I can show you the kind of 3-dimensional shapes becoming 2-dimensional shapes. Yeah. So that's it really. So I'm going to get you to do a couple of these for homework. Draw a net of each a rectangle. Okay, so we might do this one here. So question 5B. I'd like to do question 6A because people struggle with that one, so I'd be interested to see how you get on with that one. I just might snip that out while I'm here. Hang on. So we put this in here. Grand. And then, no, sorry, just bear with me 1 second. I'm going to go in here and see if there's anything good in the higher level part. That's all volumes. Sorry, I don't know where nets comes into this, so just give me, maybe it doesn't. I thought I saw, no, maybe not. I thought I saw more difficult net questions when I was making this, but maybe I didn't. Oh, look. A triangular base prism is shown. Each face is made up of equilateral triangles of 5 centimeters in length. Construct an accurate net of the given shape. Oh, that's constructing triangles. So we haven't actually done construction, so I might leave that. Somebody remind me of that when we're doing constructions, will you? Hopefully I'll remember. Right, so that's it then for your homework. 2 questions, I think. Don't think there's anything else that I really wanted to do. No. Okay, so those 2 are for homework for Wednesday. All right, guys. Thank you. Bye.